Assalamualaikum and very good day to Seshawan. Today my group will present about a modern nuclear reactors and their role in energy production. In this presentation, we will explain about what nuclear are, why this topic is important, our research process, and some challenges we face while studying this topic. First, let us introduce what a nuclear reactor is. A nuclear reactor is a machine that produces energy through controlled nuclear reaction. The main purpose of nuclear reactors is to generate electricity for home, industries, and cities. Besides electricity generation, nuclear technology is also useful in medicine, such as cancer treatment, producing a medical equipment, and it also used in scientific research to study radiation and energy. We choose this topic because nuclear energy is an important modern technology. It can be used as an alternative energy source when fossil fuels become limited. Another reason is that nuclear energy produces a low carbon emission which can help reduce environmental pollution and global warming. We believe nuclear reactors may become an important solution for future energy production. To complete our research, we collected information from different sources such as a journal, educational website, YouTube videos, documentaries, and we also discussed together as a group and compare information from different sources to make sure our presentation is accurate and very easy to understand. And during our research, we faced several challenges. First, some scientific terms were difficult to understand. Second, reactor systems were quite complex. We also found too much technical information which made learning harder. And to solve these problems, we used simplified diagrams, watch animation videos for better understanding, and divide tasks among group members to make work easier.
Hi everyone, for this presentation, I will explain the main component of nuclear reactors and the type of nuclear reactors. So, the first main component of nuclear reactors is fuel rods. Fuel rods contain nuclear fuel, usually uranium. Inside the fuel rods, nuclear fission occurs, where uranium atoms split and release a large amount of heat energy. This heat is used to produce electricity. Next are the control rods. Control rods are used to control the nuclear reaction. They are made from materials such as boron or cadmium that absorb nutrients. When the control rods are inserted, the reaction slows down. When they are withdrawn, the reaction increases. This helps keep the reactor safe and stable. The next component is moderator. The moderator slows down fast nutrients so that the chain reaction can continue efficiently. Common moderators include water and graphite. Without a moderator, the nuclear reaction would not work properly. Then, we have the coolant system. The coolant removes heat from the reactor core and transfers it to the turbine system. This prevents overheating and ensures safe operation of the reactor. Finally, the containment structure surrounds the reactors. It is made of strong steel and concrete to prevent radioactive materials from escaping and to protect the reactor from external damage. So, the next part is types of nuclear reactors. There are three types of nuclear reactors. The first one is pressure water reactor, or known as PWR. In this reactor, water is kept under high pressure so it does not boil. The heat is transferred to another system to produce steam. PWRs are widely used because they are safe and reliable. The second type is the boiling water reactor, or BWR. In a BWR, water boils directly in the reactor core, and the steam goes straight to the turbine. This design is simpler but requires extra safety measures. The last type is the small moderator reactor, or SMR. SMRs are smaller reactors with improved safety features. They are easier to build and are stable and suitable for smaller or remote areas. In conclusion, nuclear reactors are different components and designed to produce energy safely and efficiently.
Next, I will explain the process of electricity generation in a nuclear reactor system. First, the reactor core contains nuclear fuel. In the reactor core, nuclear fission occurs and produces a large amount of heat energy. Next, the control rod absorbs excess neutron. As a result, they control the rate of nuclear reaction and ensure safety. After that, in the primary system, hot water or liquid sodium carries heat away from the reactor core. Then, this hot water flows to heat exchanger. And meanwhile, in the heat exchanger, heat from the primary system is transferred to the secondary system. Consequently, water in the secondary system is heated and converted into steam. Next, high-pressure steam rotates the steam turbine. During this process, thermal energy is converted into the mechanical energy. Then, the turbine drives the electric generator. As a result, the mechanical energy is converted into electrical energy. After that, the steam is cooled in a condenser and changed back in water. At the same time, cooling water removes excess heat. Then, the water is recycled back into the system. Finally, shielding and containment vessel protect workers and the environment from radiation. In addition, the containment vessel provides additional safety. So this is all my part about the nuclear system. Thank you.
So next, I will explain about the application of nuclear reactor. First, nuclear reactors are widely used for electricity supplies. They generate a large amount of energy that can provide power to school, home, hospital, and industry. It is considered reliable because it can produce electricity continuously for a long time. Next, nuclear reactors are important in hospital because radioisotopes are used in medical treatments and diagnostic scans, especially for cancer treatment and medical imaging. Other than that, nuclear reactors are also used in submarines. Nuclear-powered submarines can operate underwater for a very long time without refueling them, making them efficient for military and research purposes. Lastly, nuclear reactors contribute to scientific research by helping scientists to use them for their experiment, testing, and studying radiation for technology advancement. Next, I will explain about the advantages and disadvantages of nuclear reactor. Nuclear reactor have both disadvantages and advantages. First advantages is the high energy production. A small amount of nuclear fuel can produce a large amount of energy compared to fossil fuels. Second, energy power produces low greenhouse gas emission, which helps to reduce air pollution and slow down the global warming. Another advantage is the reliability of lower sources. Nuclear reactor can generate electricity continuously, unlike some renewable energy that depend on weather. However, there are also disadvantages. One of it is the radioactive waste, which stay dangerous for a very long time and must be stored safely. Other than that is the high construction cost. Building and maintaining a nuclear power plant requires advanced technology and a very large budget. Lastly is the risk of incidents, which can cause harmful radiation leaks if safety system failure. Next, I will explain about the advancement and issues of nuclear reactor. Nuclear reactor have both advancement and issues. The first advancement is safer reactor technology, where the modern reactor have improved system safety to reduce the risk of accidents. Second advancement is the small modular reactor or SMRs. They are built smaller, more flexible, and cheaper to compare to the traditional reactors. Other than that, by improving cooling system will help to prevent overheating and improve safety. However, there are still issues. The major issues is radioactive waste, which must be stored safely for a very long time. Another issue is the public concern about safety, as many people worry about the radiation and accidents. Past disasters like Chernobyl and Fukushima have also increased the fear about nuclear energy.
Okay, so I will present about career in nuclear technology and future development. For nuclear engineering, the job scope is for design and improve nuclear reactor, solve technical problem in power plant, and ensure reactor safety and efficiency. For the skills needed, they need mathematics and physics, critical thinking, and computer simulation. For reactor operator, the job scope is control reactor system, monitor safety procedures, and respond to emergency. And they need skills needed like decision making, attention to detail, and technical operation skills. We have two skills like skill development and soft skills. For skill development, such as computer engineering software, technical skills, and radiation safety. For soft skill like communication, leadership, and teamwork. Okay, other than that, I will explain about experience to enhance skill like internship at energy companies, engineering laboratory work, and safety workshop and seminar. While experience is very important, first, it can build confidence, and secondly, we can train ourselves to work at real workplace. Okay, next I will explain about short-term goals, long-term goals, and career challenges. Firstly, for the short-term goals, it can achieve excellent result in physics and mathematics, and also can improve communication and technical skill. For long-term goals, it become a certificate in the nuclear engineering and work in international energy industries. For the career challenges, it can be advanced reactor safety system. Secondly, public education about nuclear energy, and strong teamwork and monitoring system. For the conclusion, in my opinion, I think nuclear technology offers many exciting career opportunities for future generation. With the right skill, education, experience, students can contribute to safer and cleaner energy production. Modern nuclear reactor will continue to play an important role in global generation energy development.